Okay, these notes are hydrate notes. Okay, a hydrate is an ionic compound that has water molecules attached to it, hence the word hydrate. To name a hydrate, you first name the ionic compound, then you name the water part using prefixes and the word hydrate. Yes, I said prefixes. You know, mono, di, tri, tetra. Guess what? You're going to have to know them again. In fact, on Monday, there's a quiz on the prefixes. So you have to know them. I told you they would come back to haunt you again. Okay, so let's look at this first one. It's CuSO4.5H2O. Okay, this is the copper 2 sulfate. CuSO4 is copper 2 sulfate. The 5 is penta and water is hydrate. So we have copper 2 sulfate pentahydrate. Okay, here are the prefixes. It's a prefix review. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Okay, so there's a quiz on this. Know this. Okay, finding the empirical formula. Oops, I better put empirical formula of a hydrate. It is different, well, a little different than finding the empirical formula of a compound. Same basic principle where we're going to take the mass over the molar mass to get the number of moles, and it is a mole ratio. When we were doing the empirical formulas, it was actually a mole ratio of carbon to hydrogen to oxygen if you had like C2H3O or something like that. Those were mole ratios. We just got them down to the whole number mole ratio. Okay, we're going to be doing the same thing here. Now, if you look at the copper 2 sulfate, the anhydrate means without water. So this is the anhydrate. It's the ionic compound, okay? So it's the moles of the anhydrate to moles of water. And in this case, it's a 1 to 5. Now, it's always going to be 1. This will always be 1 when you're done. So it's 1 to something. Don't know what the number is, but it's always 1 to something, okay? Okay, back to the moles of the anhydrate and moles of the water. Similar to what we were doing with the empirical formulas of a compound, we were actually finding the mole ratio. And we took the mass that we were given, either the percent or the mass, and divided it by the molar mass to get the moles. You're going to do the same thing here. You're going to take the grams of the anhydrate, because you're going to get a mass. So the mass of the anhydrate over the molar mass of the anhydrate. And then you're going to go, it's a ratio to the grams of water over 18.02 grams per mole, which is the molar mass of water. Now, this will give you a decimal. So you're going to get the proper ratio, only it's in decimals. We need whole numbers. So just like when we were doing the empirical formula with the compounds, we're going to divide by the smallest number of moles in order to get 1 to something, and it should be a whole number. Now, in this case, you're always going to divide by the grams or the moles of the anhydrate. That's always going to be the smallest. So divide by moles of the anhydrate. And you'll be rounding to the nearest whole number. There's no halves in this one. You don't have to worry about getting a half. In fact, if you do get a half, you've done something wrong, but you shouldn't. Okay? Example 1. A 1 gram sample of a hydrate of CuSO4 is heated and 0.639 grams of the anhydrate remains. Okay, we're not going to use a 1 gram sample, but we're going to actually be heating either copper 2 sulfate or copper 2 chloride. Both of them have more than one hydrate. So you're not going to know which one you're going to get as far as which hydrate you're going to get. Okay, you get one of 2. So you're going to have to calculate to figure out which one it is. But either way, you're going to heat it. It's this blue stuff, and it's going to be white when you're done because you're going to drive off the water. Now, the question says how much water was removed. Well, I think you guys can figure out how to find out how much water, but I'm going to show you the way I want you to write it so that you don't get confused with anything. So, whoops, guess I should start my pen. So 1.00 minus. Now what I want to see here is the substances listed. 0.361 grams of water. This is very important. I will take off points if I do not see grams of copper 2 sulfate and grams of water in this step. You need it because it will help you keep track of what goes where. If you just have 0.639 and 0.361, you might put them on the wrong spots. Okay, now at this point, you're going to take 0.639 grams of CuSO4 over, first we need to get the molar mass of CuSO4, and that's 159.60 grams per mole. Okay? So we're going to put 159.60 grams per mole. Now remember, to get this number came from the periodic table. I added a Cu plus an S plus 4 O's. Okay, now the next one is 0.361 grams of H2O over 18.02 grams per mole. Now, very important, I better see it written like this with the substances listed. After this point, you can write down just all numbers and I don't care, but I need to see the substance listed in this step. Okay. Now, when you take the 0.639 divided by 159.60, you get 0.004. And when you take 0.361 divided by 18.02, you get 0.02. Whoops, actually, no, you don't. You get 0.02, not 00. Ah, typo or righto. Okay, now obviously the small one is 0.004, which is the anhydrate. When you do this, you get a 1 to 5. So it's CuSO4.5H2O, and I've already named it in another slide. So you should be able to name this one copper 2 sulfate pentahydrate. Okay? Example 2, a 2.50 gram sample of a hydrate of calcium chloride is heated and 0.60 grams of water is removed. What's the name of the hydrate? Well, obviously in order to name it, you've got to calculate or figure out what the formula is. So we're going to do, now remember, I need to see what everything is. So 2.50 grams minus 0.60 grams of water gives me 1.90 grams of CaCl2. Very important you do it this way, because last year I didn't have them do it and everybody kept putting the 0.60 over top of the molar mass of calcium chloride. They kept getting confused as to which is which. If you write it this way, you don't. Now, the molar mass of calcium chloride is 110.98 grams per mole. So we're going to take 1.9 gram, 1.90, same difference, grams of calcium chloride over 110.98 grams per mole, 0.60 grams of H2O over 18.02 grams per mole. Now once again, this is where I want to see the substances. After that, you can write just straight numbers. So 0.0171, 0.0333, divide everything by 0.0171, you get 1 to 2. So it's CaCl2.2H2O, calcium chloride dihydrate. Okay, hopefully that was easy enough for you. If not, I will be going over it on Monday. Make sure you have this stuff written down, not just watched. I mean, if you watch the video, that's great, but you need to have it written down in order to be able to do the lab on Tuesday. So hopefully everybody has a good weekend. So I will see you on Monday. Bye.